everyone, it's Miss Smith. I hope you've been managing to keep yourself warm the last couple of days and that you were able to stay off the roads and stay safe today. I'm going to take you through the biomodeling assignment and show you what it looks like on Java, as I understand that some of you are still having some Java issues. First thing you need to do is, if you didn't bring your course pack home, you need to go to your Greenhouse page, whether you're C period, D period, or if Mr. Groff's classes are watching this, A or E or F period. Go to the resources section and you should find that what'll come up, you'll have all kinds of things right here. Chapter 2, Biomodeling assignment. That's the one you want to click on. When you do so, it'll bring this assignment up, which is the course or the pages that we handed out to you in class last week. When you're ready to go, we're going to click on open up a new browser window, type in the URL address for the biomodeling assignment, and of course we want to accept the risk and run Java on this site. So the first things the instructions tell you to do is to go here and then click on monosaccharides, and then we're going to click on glucose. One of the things that it tells you on your Word document is that the gray symbolizes carbon, the white symbolizes hydrogen, and the red symbolizes oxygen. Every time there's a junction here, that's what's going on. So there's one carbon atom right here at this junction, there's a carbon atom here at this junction, carbon atom here, and so forth. Now in this image here, we can count the carbons and we can see that there's 1, 2, 3, 4, 5, 6 of them. So one of the things you're going to need to do is to write out the chemical formula for glucose, which hopefully you already know and is already well ingrained in your mind. You need to tell me what shape this is, so you're going to need to count the number of sides and think back to math and geometry and what we call a figure that has 6 sides to it. Look that up if you don't know it already. This is the ring that is at the heart of the molecule of glucose. You need to count how many carbons are in the ring, not in the whole molecule, but in the ring, as well as what other atom is forming one part of the one point on this ring. That's that atom right there. And look back and see what color that represents, or what element that color represents. And then you need to count how many of each element there are. So I'll give you a chance to do that right now. Once you've done this, you can move on to the next one after you've filled in all of question number 1, and we can go back and we can click here on fructose, and you'll notice that this is a little bit of a different shape. First thing that it asks you to do is to say what shape is the ring. Notice that there are 1, 2, 3, 4, 5 sides on this ring, so you should know the name of that polygon, and you can put that on the first blank. And then it asks you, of the 6 carbons that are in this, how many are in the ring? So you'll need to count how many carbons are in the ring, and then tell me what other atom this is here. Then count up in the entire molecule the total number of carbons, the total number of oxygens, and the total number of hydrogens. So I'll give you a couple of different views here. You can pause it if you need to so that you can count these all up. That's probably your best image right about there. Alright, now we're going to go back to the index and we're going to choose disaccharides. Now think about what this term means, disaccharides. There are 2 monosaccharides that are going to join to form sucrose, and if you look here in the instructions, it tells you what they are. However, your question asks you to say what they are and then say which one is in green and which one is going to be shown in purple. So next we'll look at this molecule, and here's our molecule of sucrose. So it looks like glucose is in the green and fructose is in the purple. Okay, so we're going to click this box here that says show each atom in its own color. And there they all are. So the next thing that you're asked to do is count up the total number of carbons. So I'm going to show this view to you right now so that you can count up the ones in this molecule of glucose that are here. Pause it if you need to. And now I'm going to tilt it around so that you can count the number of carbons in this molecule of fructose. There, I think that's a pretty good view of it. You're going to need to count up the carbons. You're also going to need to count up the total number of oxygens. Remember that oxygen is in red. So I'll try and move this a little bit slowly so that you can count them. Again, feel free to pause this. And there's all your oxygens. And now you need to do the same thing for all of the hydrogens. Pause it if you need to so that you can look at all of them. Now the next thing you need to do is to write the chemical formula with carbon, then hydrogen, then oxygen. And remember, the numbers that go along with each counting of atoms go in subscript kind of down beside each letter. Now question E says, which atoms in the sucrose formula aren't exactly 2 times what you have in the 2 monosaccharides? If you're not sure how many we had in each of the monosaccharides, flip your page over and go back to page 1 of your assignment. That's what you just did. So take a look there and see which ones aren't in sucrose, which ones aren't exactly double or aren't exactly what you were expecting from the chemical formula for glucose and fructose. There's 2 elements and you need to say which element it is and how many we seem to be missing. And then for question F, you have to say, why doesn't sucrose have exactly 2 times the number of each atom as the 2 monosaccharides? So why don't we have all of the atoms of glucose and fructose in our molecule of sucrose? Think about the fact that this is a disaccharide and think about what happens when we join 2 monomers to make a polymer or even a dimer, which we've done here. What kind of reaction is that? All right, we're going to go back to the index and look at polysaccharides. Remember, poly means many. So the first one we're going to look at is we're going to look at cellulose, amylose, and glycogen. And if we read here in the stuff at the side, we see that cellulose its structure is formed by the linkage of D-glucose. Don't worry about the D, just know that they're glucose molecules. And then if we look down at amylose, which is another one that we want to look at, we see that it is also formed by D-glucose. And then we're going to be looking at glycogen, and I can tell you that glycogen is also made of glucose monomers. So why is it appropriate to call each of these polymers? Well, let's take a look at cellulose. Here it is. All right, so you can see that we've got a bunch of glucose molecules linked together. It's not showing you the hydrogens on here, and that's okay because we want you to see the overall structure. Now we're going to look at a bit of a larger molecule of that. When we look at the linear structure, look at this molecule. This one is showing the hydrogens, but here is a molecule of cellulose. So you'll notice that it's long and it's a pretty straight chain. If we look at the next one was amylose. If we look at that one, you'll notice that this is not a very straight chain. And if we look at a larger molecule of amylose, we'll try and look at a larger molecule of amylose. It probably wants to work, but my recording isn't working. There it is. So here's a longer version of amylose. We've got more than just what we had seen just before. And if we look at this from the end, oh, what shape do we see? It looks long. We look at it from the end. Oh, look at that. All right, so you can make your own responses there. And now lastly, we're going to look down at glycogen, which again, remember, is a bunch of glucose molecules that have been put together. Here's glycogen. And you'll notice that this has lots of different branches. It's not just one long tube or one long chain. There's branches off to the sides of this one as well. This actually enables glycogen to store more energy in a smaller volume, which makes it easy because glycogen is what we use to carry excess starch around. And if we have to carry it around, we want to get the most bang for our buck and get more energy in smaller volume if we're carrying it around. All right, that's the end of the carbohydrate section. I'm going to pause and I'm going to make a separate video for lipids and for proteins.